So if this is the question you're given, where would you start? So you would try to factor it by grouping, right? Like we know. If we tried to factor it by grouping, I would take out an x squared, and I'd be left with x minus 8, right? What could I take out of these two that's going to leave me with an x minus 8? No, uh-oh. That's not good, is it? Okay? That means I can't factor it by grouping, can I? Okay? So that means I have to have another way to try this. Okay? So I could start guessing, right? That's our favorite thing to do, right? Just randomly guess. Okay, so if I'm randomly guessing, how many numbers do I have to choose from? All of them. I have all of the numbers to choose from to try to figure out what the factors of these are, right? I don't want to guess for an infinite amount of time. I'm going to be hungry for lunch pretty soon. Or dinner. Or breakfast. Something. I'm not going to want to factor for infinity. Okay? So I would rather have a way to go about figuring out like specific numbers to try to choose. Oh, there's a way. Okay? That way is called the rational root theorem. Okay? Rational root theorem. If we call this number P and we call this number Q, the rational root theorem says we should really try not all the numbers, but the factors of Q divided by the factors of P. That's what I should try. Now, when I say try, what do you think I'm talking about? I should try what? Well, if I'm trying to find the factors, let's think back for a second to a couple days ago when we were doing, let's even think back to yesterday when we took our quiz. You saw those extra credit questions on the back? Have you ever seen any of those before? You'd actually seen one of them before. It just didn't have the same kind of directions. It said, here's an equation. Is x minus 3 a factor of this equation? Well, what would make it a factor of the equation? Think back to when we did synthetic division. How would we know something divided evenly into another polynomial to know if it was a factor? If the remainder was 0, right? If the remainder was 0. So I could choose any random number, an infinite amount of numbers, and try synthetic division with this problem to see if the remainder was 0, right? But I don't want to spend all the time. We already talked about that, right? This gives us a better idea of where to start. Okay? So tell me, what are the factors of Q? What are the factors of 20? 1, 2, 4, 5, 10, and 20, right? Did I miss any? So I need a positive 20. And you're telling me these are all the factors? So 1 times 20 is 20, 2 times 10 is 20, 4 times 5 is 20. And that's it? Oh, so we could have like negative 1 and negative 20? Isn't that equal positive 20? Negative 2 and negative 10? So I need really the positive value and the negative values of all these numbers, don't I? Okay. Divided by the factors of P. Well, what are the factors of P? 1. Still positive and negative though, right? Okay. So now we just randomly start. I mean, this helps us, right? Instead of having an infinite amount of numbers, now we only have 12. Positive 1, negative 1, positive 2, negative 2, and so on, right? That's only 12 numbers. That's good. While it's still 12, it's way better than an infinite amount of numbers, isn't it? So if we just start dividing these into this polynomial, what are we looking for again? A remainder of 0. That's exactly right. We're looking for a remainder of 0. Okay? So where do you want to start? What number do you want to start with? Negative 20? Okay? Negative 20. Remember how to set up synthetic division? 1, negative 8, 11, and 20. And my remainder is going to be under the 20, right? Okay, I'm going to go slow for a second just to remind you how to do synthetic division. Bring down the 1. Multiply. Negative 20. Add. Negative 28. Multiply. Ugh. Okay, I'm going to stop for just a second. And I'm going to think logically for just a second. If I add these and multiply by another negative 20, am I going to get a negative 20 right there? Is there any way for me to get a 0 right here using negative 20? No. So I'm not even going to finish this. I'm going to stop because I'm smarter than that. I don't need to work harder. I need to work smarter. And I'm choosing to work smarter right here. Okay? So what should I try next? So are we just jumping around? I multiplied these two. Are we just going to jump around? Is that what you guys want to do? I mean, that's a good song and all, but when you jump around, you just have to make sure you have a good idea of what numbers you've already done so you don't redo them. Fair enough? 1, negative 5, negative 13. Is that 65? It's not going to happen, is it? So can I stop? Yes. Okay. What should we try? 2? We can try 2. 1, negative 8, 11, and 20. 1, 2, negative 6, 12, 23. Uh-oh. 1, negative 8, 11, and 20. 1, negative 7, negative 7, 4, 4. Positive 5, okay? Positive 5. 1, negative 8, 11, and 20. 1, 5, negative 3, 15, negative. Negative 4, negative 20. Ooh. I'd prefer if you not talk about doing each other's homework for money in front of me. So, there's another thing that we have to know now. What are we doing? Like, what is our goal? Well, look back at the problem. It's an equation, right? Set equal to 0. When an equation is set equal to 0, what are we usually trying to do? Solve it for x. That's exactly right. Okay? So we kind of need an idea of how many solutions we're going to have, right? So there's this thing called the fundamental theorem of algebra. Does that sound pretty important to you? The fundamental theorem of algebra? That's pretty important, isn't it, right? The fundamental theorem of algebra says whatever the highest exponent in your problem is, that's the maximum number of solutions that you should get. Well, we found one, right? We found one solution. How many more are there? Maximum of 2 more, right? We can't get 4, can we? Could we get 2 solutions? Yes, because it's the maximum number of solutions. That means there can be less. Could we get 1 solution? Yes. Okay. So I found 1. Now, again, working smarter, I'm not going to do a bunch of more synthetic division unless you just really want to, because I remember what this means when I get an answer in synthetic division. I remember that that's my remainder, so that's my constant, that's my x term, and that's my x squared term, right? So this says x squared minus 3x minus 4. And I think to myself, I'm pretty sure I can factor that. Oh my gosh, it's almost like we spent 4 days on factoring for a reason. AC is negative 4, isn't it? And B is negative 3. So because my leading coefficient's 1, I can use my shortcut, can't I? Well, what multiplies to be negative 4 and adds to be negative 3? Negative 4 and positive 1. So I suddenly have all three of my factors. I know what you're going to say. Hold on just a second. I'm getting there. I promise I am. Okay? X minus 4 and x plus 1 are two of my factors. Where's my other factor? Yeah, it has to do with this, right? Because I know that gave me a 0 for my remainder. Now, some of you are thinking something is wrong because we already tried a 1 and it didn't work. Isn't that what you were thinking? We already tried a 1 and didn't work, except we forgot one thing. We forgot that when we're asked to divide with synthetic division, this is what x equals. So if x equals 1, I would have to subtract 1 to both sides to get